Hi, good morning and welcome to the ZP Developer Zone. So we do this webinar at every Thursday at 8 a.m. London time, and we'll just sort of basically jump straight into it. So the first thing to say, there is the ZP Academy. A lot of what we'll talk about today is always fairly technical. We'll touch upon lactate sensors, which for example are amperometric, and if you're not sure about amperometry, check out the ZP Academy. Um, we do get a lot of technical questions during the week, and so we bring them to these webinars really because I think it's sometimes easier to illustrate answers than to just a whole series of emails. So we'd like to have these webinars once a week. So if you have any technical questions, obviously reach out to us at ZP. And we also have very good collaborations. So I think over the summer we've been showing images of ZP developers who have actually been to our labs, mostly in the UK. But it's worth saying that we've actually got in a collaborator coming in from Canada this week, and they're coming into our Norway facility. We obviously post jobs. We have our ZP Developer Zone website, and we have workshops, and we have workshops. Now, I want to just jump into the workshop part and say, if you're interested in either continuous glucose monitoring or you're interested in wearables, then we are having a workshop in Norway, and I put a link. So any links that you see that pop up, I've already put them underneath the video. So I hope that's, let's say, useful to you. Now, what I want to do now is just jump in and forward a little bit more and say I had three questions, or rather, we've had three questions this week that have come in to ZP. The first question was actually regarding lactate monitoring in athletes. And the other question was measuring chillies. And the question was specifically about measuring chillies by HPLC, high pressure liquid chromatography. And then the third question was we're increasing the information that we're putting out on the glucose to API developers kit. So let me go forward a little bit faster now. So question number one is, at Zimmer Peacock, we have a whole range of biosensors, from glucose to lactate to potassium, potentially to hydration, things like pH, for example. But around sports, we have also, specifically for sports, sometimes the testosterone and cortisol are also interesting. So we have these range of sensors. Now, there's many ways of actually delivering a sensor to or on the body. And I'd like to sort of essentially jump straight into that now and say, look, let's have a sort of little model for the body. And what I've done here is just show look, we've got the epidermis, which is the sort of top layer of the skin. Underneath that, then we have the dermis, and then underneath that we have sort of subcutaneous tissue. Now I'm going to show you three configurations. So if we were specifically talking about, let's measure lactate in an athlete. Now the three ways that we could do it is we could have a sensing system where we actually had something like a wire or a filament that goes down into the tissue. And these can be something like 6 millimeters long. And unfortunately, I mean, the longer is sometimes the better when it comes to sensing. The deeper we go, then the more meaningful the sample that we're actually trying to measure. Like a clinician, if they were measuring lactate in an athlete, and when I say athlete, it could be a mammalian athlete, it didn't have to be limited to humans, but they would take a blood sample. Now, the problem with that, obviously, is you have to take that blood sample and you can't have continuous measurements. With lactate, it's an interesting one because when you work out, the lactate kind of goes high and then there's a recovery period. And, people want to know what that recovery period looks like. If you recover quickly, then either you haven't exercised enough or actually you're showing that you're in a good, healthy state. Whereas prolonged recovery could show that you either worked out very hard or you worked out very hard and you're actually quite fatigued. And so it's hard to recover. But it's a little rule of thumb. I think that the biosensing data quality is better the slightly deeper we go. So the wire and filament is sometimes maybe the best configuration. It's also the most intrusive configuration. So if you look at people like Abbott and Dexcom and Medtronic, they often have this wire configuration on their continuous glucose monitors on their CGM. So if we were talking about lactate, it seems like, and I don't want to, a good idea to, if you're specifically doing lactate, then to have the lactate also in this configuration. Now, you do have companies that have attempted this in the past and are definitely attempting it at the moment, is to have microneedles. Most of the microneedle biosensor work is actually going on in the glucose space, in the CGM again. But the principles can also be configured over to lactate. Now, the risks here are this, that there was a company in San Francisco called Sano Health, and I think at one point they were actually funded by Fitbit, and they spent about 15 million US dollars at least trying to do microneedles for glucose. And there was another company before them also in Silicon Valley that tried to do microneedles. So there's been a few attempts. Now, at the moment, the most well-funded attempt to do microneedles for measuring glucose in diabetics, for example, is BioLink, and they're spending, or they've raised of recent, they've been going for 7 years, they've raised 100 million US dollars. I say that, see, because it sort of tells you the difficulties in doing some of this work. But that said, you can then have a sort of less invasive way of than the wire, which is this microneedle format. And then the least invasive or the non-invasive would be just to have sensors on the skin itself. Now, in a minute, I'm going to talk about sweat measurements. There are groups out there, again, mostly in the diabetic space, who are trying to use optical measurements to measure glucose non-invasively. In fact, one of the most well-funded attempts at measuring glucose non-invasively was done by the company that manufacture this. This is obviously Apple Watch, and Apple have a couple of patents out there. None of these techniques have worked. So if you are attempting to do a non-invasive optical or electromagnetic spectrum measurement of things like glucose or lactate, please read a book called sort of Non-Invasive CGM, and then it's dash Hunting the Deceitful Turkey. That's a book that you really should read. Right, so let's go back to the point here. So at ZP, we have a number of biosensors. People are very interested in measuring lactate in animals or in humans, understood that. You've already immediately got three choices, whether to go wire, microneedle, non-invasive. I think wire is clinically the least risk, and non-invasive is clinically the highest risk. And I also think that wire is possibly the lowest cost option at this moment because it's the most matured technology. So we have those wire technology at ZP, we have the microneedle technology. Now, we don't use optical technologies to do non-invasive measurements. We actually have a sweat patch. Now, that said, I was recently asked, whether lactate in blood versus lactate in sweat was actually well correlated. And I found a paper by a guy called Seamus Higgins. Seamus is known to me, he's a good scientist. And there they demonstrated that there wasn't a good, or rather their review said there wasn't a good correlation. So just be careful that, for example, if you're trying to measure things like glucose and lactate and you think you're going to do it in sweat, there might not necessarily be a good correlation between the sweat measurement and the the blood measurement. And you might have to sort of do things like compensate for the sweat rate, etc. So it's not easy. So if you came to me today and said, I want to measure lactate in athletes in a continuous measurement, then I would say go for the wire format, or more risky, go for the microneedle format. The reason that it's sometimes worth the risk on the microneedles is it is probably more acceptable. I've stuck these microneedles on myself. It's nothing. You really don't feel it. I've also put these wire sensors on myself as well, and I feel like that's okay as well. It's just whether some people have a higher sort of tolerance to discomfort than other people. All right, I shall go forward a little bit more now, and just so you know, at ZP we have this range of sensors, including glucose and lactate. We know that everyone wants to, not everyone, but lots of people want to put them in this wearable format. We do have a platform and a strategy for kind of going from idea to data pretty quickly. We call it the ZP Accelerator. So you choose the sensor that format you're interested in. We can put that then into a wearable So for example here, bands that I've demonstrated, that's obviously worn around the upper arm here. We have the ability, and we have these apps, the ability to have an app on a smart device. The smart device makes a Bluetooth connection to the electronics itself, and then the smart device is great because it uploads the data to our proprietary database called Julie. Once we get the data into Julie, then we can analyze the data. Now, the nice thing about working on something like glucose or lactate is there's already a device often on the market. You know, I mean, I think the term is for it is predicative device. I don't think I know what it is. It's a hard word to say, but a predicative device on the market. So, for example, here I'm showing the epoch. So if I was trying to measure lactate in an athlete, we would have the wearable sensor on the athlete, and then we could also then measure, for example, their normal lactate bloods on a handheld device and start correlating the signals. And this is just a strategy because people often do a lot of lab work before they start testing the sensor in a real situation and in real samples. And our strategy, because of the technology we've built up over the last years, is no, let's get the sensor onto the person or onto the mammal, and let's start getting that raw signal on what we would call a prototype or minimally viable product, and let's also start getting clinical samples by drawing bloods or pricking the finger. But let's get, if there's a predicative device for measuring, for example, lactate or glucose, it really helps us because we can start doing a correlation quite early on and really making our signal extraction algorithms much more efficient. And again, if a link ever pops up in this, then you should know that there'll also be links underneath this video, and you can sort of find background information on that. Wire sensors. Now, our wire sensors, I sort of said that for ZP, the least risk option is the wire. And for us, it's because actually we've put the most money into the wire sensor. So we have a wire sensor for measuring glucose and cortisol in fish. I think the whole project is funded for something around about 2 million. We have a good technology stack in terms of electronics and the sensor itself, and you can find that at a site called fishtag.zimmerpico.com. Now, microneedles at ZP, we also have, there's a link that's just popped up. That link is also underneath the video, and it will show you that we actually have a whole bunch of like microneedle technologies. As I say, there's a bigger gap between being able to do a proof of principle using a wire sensor and a proof of principle doing a microneedle sensor. I think microneedles are tougher, but I think the acceptability by patients and users will be better with microneedles. With microneedles, it's interesting as well because I'm just sort of thinking a little bit that if you were measuring lactate in a human, you might need a certain length of microneedle. But if in fact, in some animals, depending on the thickness of this sort of dermis and epidermis, the microneedles might have to be longer. So that just has to be kind of taken into consideration as well. But we do have these microneedles on the ZP website. All sorts of geometries, and we would just choose the one that we thought was most appropriate for the, let's say, the animal or the application at the time. Now, I did say that the hardest one is, here I call it sweat analysis, but it's sort of sweat analysis falls into this kind of category of non-invasive sensing. Don't think that non-invasive sensing is easy. If Apple have done it and they've well funded it, and I have a list of companies that have tried non-invasive glucose monitoring over the years, and they've not been successful. Now, this is because many of these companies try to do it optically, and so when you try to do it optically, it's the question what your hypothesis is. I'm going to send something like infrared spectroscopy, sometimes nuclear magnetic resonance signals. I'm going to try and send UV, infrared, Raman. I think these have all been tried. Maybe not UV so much, but infrared and Raman have definitely been tried. So they're going to send this excitation, this photonic excitation through the skin. They're going to look at the signal that kind of comes back out. And from that, they're going to be able to pick a needle in a haystack, which is the glucose molecule. It's probably worth saying like that water, the concentration of water is, the units are a bit silly here, but it's 55 molar of water, and what you're trying to measure there is 5 millimolar of glucose. The noise to signal ratio when trying to look at things like spectrum is really, really hard. And I do see this a lot. People have this kind of like, I'm going to do it, but you really should read the history on non-invasive. And as I say, the book Hunting the Deceitful Turkey, a hunt for sort of non-invasive CGM, should really be read. I just want to say hi to Albo Mayer this morning. Hi, Albo. Nice to see you. Albo was one of our interns. Did a good job on, rather interestingly, something that was called HPLC, which we'll jump into in a minute. So let me jump. So I just made a sort of bit of a conversation about non-invasive glucose, non-invasive sensing rather. But let me get back to the point that when we do non-invasive, we often do it by trying to do sweat. We have a sweat patch on our website. It's interesting because when you think about sweat patches, it's non-invasive. You've then got to make the hypothesis that the sweat is reflective of, is clinically relevant, which could be the case in hydration. It may not be the case in glucose and lactate, but we do have some technology or some information about that on our website. So if I was to summarize this, then I'm going to sort of summarize it by saying, if you're trying to make a lactate measurement in a athlete, I think the wire is the lowest cost, lowest risk way of doing it, followed by the microneedles, and non-invasive starts to come out of the ZP territory. But you really should do your homework on non-invasive. People have been trying this for over 20 years, and it's pretty tough. But of course, entrepreneurs should always, try new things. So I'm going to go to question 2 now. So question number 2, it does involve some HPLC, high pressure liquid chromatography. So the question that came in is, I'd like to buy HPLC, high performance liquid chromatography, to measure chili hotness. So there is a procedure for measuring capsaicin in chilies by HPLC, and I should probably jump into that a little bit actually. So just to give us, for some of you who watch this, not for Albo who's online, but an HPLC looks like this. It's quite a large box. It could cost you $50,000 to $60,000 to get a fairly basic unit. You'll need a really good lab in order to house this unit. These are scientific instruments. They don't like being in dusty, dirty environments. They take what's called solvents, so you have to start buying big bottles of solvents. I'm even thinking about that lab. It probably has to be quite air conditioned. We're starting to have some heat waves around the world. So it has to be in a good system, air conditioned, clean. You have to have solvents. You have replacements like columns. These columns and solvents can be expensive. You have to get rid of the solvent, so you have a waste of space disposal problem. And then you need a fairly good scientist to maintain this equipment and to run this equipment. So we understand the question, which is, I want to measure chilies by HPLC. What we find out is, other than the largest chili growers might have HPLC systems, but generally HPLC is actually too expensive for the market. There's just not the margins in the market to be able to afford HPLC. But at Zimmer Peacock, we actually do have an HPLC, and we definitely have measured these molecules by HPLC, and you can sort of find that on our website. Now, what we have is, we have the HPLC because we use it to validate, but we actually use the FoodSense, and I've put an image on top of an image here. And the reason I've done that is just to give you a sense of scale. So the HPLC is quite big, and the FoodSense is definitely small. The FoodSense I could hold it in my hand, no issue. So it's not only smaller, but actually it's also an order of magnitude less expensive. So let me jump into that a little bit. So we do not make a HPLC for measuring the hotness of chilies. We run it as a service, and we own HPLC. And we use HPLC to validate our FoodSense, but actually what we provide is the FoodSense. It's probably worth saying that we've done internal correlations between HPLC and FoodSense, but more importantly, we've also had academic groups do it as well, where they've looked at the HPLC method, they've looked at the ZP FoodSense method, and they've looked at the correlation. And this academic was actually really quite impressed because there's such a difference. In order to do the HPLC method, he had to kind of collect the sample, send the sample out, paid for it. It wasn't that cheap. Whereas with these FoodSense method, he made the sample, he put the test, he put it on the sensor, and he got a result immediately. And with us, he tested in triplicate. With the HPLC method, he only did single measurements. And why did he only do single measurements? Because he couldn't afford to do triplicate. But now, what we've discovered actually is that if you have a chili sample and you send it to, say, 3 different labs for HPLC analysis, you'll get 3 different answers. And this is just the elephant in the corner, or the big secret is different labs, when analyzing chili samples for the hotness, will give you 3 different results. Different lab procedures, different sensitivity in the equipment. It's not, you're not going to, the truth is not necessarily coming from HPLC. But this is an independent paper. It shows a good correlation between FoodSense, which is a handheld instrument, and the HPLC method. And you can find the paper for free there. And this is FoodSense, and this is the link to it here. Now, the last one really is about glucose to API. So at Zimmer and Peacock, we think that there's a lot of companies out there with a lot of good ideas, a lot of entrepreneurs, a lot of startups. And for example, they want to measure glucose in food, they want to measure glucose in diabetes. But what's kind of holding people back really is the platform on which to work. So what we've done is we have a glucose to API starter kit. Now in there, you get the glucose sensors. Now you can buy something from like 2 sensors to 5 million sensors. I don't suggest you get 5 million sensors. I suggest you just get 2 sensors. So 2 sensors, purchase 12-month subscription to Julie. Julie is, I've mentioned this database a lot. Julie has the ability to allow people to pull data out of Julie using an API, an application program interface. So this means that you could be essentially a software engineer, and you can buy all this test kit and all this hardware, get the data up to the cloud, and then pull the data across to your cloud using an API. So the 12-month subscription to Julie. Now, because you're in development phase, you might want to reuse these glucose sensors. So we have a rinse solution here. It's just for washing the glucose off the sensor so you can do some more testing. We have the meter itself. So there's a little image of the meter. The smartphone doesn't come with it, but you'll need an Android smartphone. And then glucose test solutions, just so you can kind of get some glucose readings off your sensor. Now, this test kit is not intended to give you amazing glucose readings. It's intended to get you from a glucose sample through the electronics onto the smartphone and up to the cloud, and then from the cloud to your cloud. So it's a way of you working on that entire workflow. Because once you've done that, you've kind of laid the foundations at this point, that I can get glucose sample, I can get the signal to the cloud, and I can get the cloud to my essentially my cloud using the API call. So this is the kit. So you need essentially a minimum of 2 glucose sensors, 12-month subscription to Julie, a biosensor rinse solution so you can wash the sensors and reuse them, the meter itself, and the glucose calibration solution. So you can, reason we say get all of this stuff is because then it reduces all the variables. We've made it all. We know what the quality is. You can use it and essentially make much more progress. And again, I've put a link to this, and there'll be a link underneath the video below. I suppose when you look at what Zimmer and Peacock is doing is, we've talked, this morning we've talked about measuring lactate in athletes. We've talked about measuring the hotness of chilies. We've talked about glucose to API. You can see what we're doing is taking tests that normally have to be done in a laboratory, reducing them into small form factors, and in some cases making them continuous measurements as well. And so it seems, like we've got a lot of stuff going on at ZP, but it all has a focus. So what I want to do is just sort of summarize and say, so lactate monitoring in athletes, I would do it on a wire sensor format. Secondly, I might then try the microneedles, but non-invasive for lactate, that's pretty tricky. Measuring chili, we don't do an HPLC for chili. We own an HPLC for chili. We run it chili measurement on that as a service. We have actually primarily owned it because we validated our FoodSense technology. And then expanded info on glucose to API, 2 glucose sensors, 12-month subscription to Julie, rinse solution, the meter itself, and then those glucose test solutions that we also have on there. And if you get all those, then you're done. I do appreciate Alba coming online this morning. As I say, Alba's been with us for 12 months last year, so it's nice to see you again, Alba. And we might need you on that HPLC again. All right, so I want to say thank you very much for attending this morning. Have any questions, technical questions, Zimmer Peacock, please post them or send them in to us. There's our, you can find us on our various websites. If you have technical questions, then we'll answer them in this format as we do. I just want to say thank you very much, and hopefully speak to some of you next Thursday at 8 a.m. London time when we do our weekly webinar. Okay, thank you very much.